Team 51 was tasked by GHSP to shift a new type of transmission. The transmission shown is called a CVP and works by changing the rotation of the planetary spheres. The planetary spheres shift the gear ratio between the two rotating disks. The transmission had to be shifted by the use of a shifter that moved 8.4 degrees in either direction, with a load of 62 Newton meters. The actuator we designed connects to the shifter by a shoulder bolt that is connected to a steel housing. The steel housing is translated by the use of a ball screw. The ball screw is being rotated by spur gears that have a ratio of 4:1, which is attached to a 12-volt DC brushless motor. The position of the actuator was measured with a linear potentiometer whose signal was being fed into a Robotech controller. This was used as feedback for a PID controller that was tuned to meet the requirements of our system. To increase the lifetime, a linear rail was mounted to reduce the moment on the ball screw. Finally, the entire actuator was encased in an aluminum housing. Here you can see the actuator moving through the profile of the design cycle with an applied force from a hydraulic cylinder that simulates the force from the transmission. The actuator consists of 4 assemblies. The DC motor provides torque to the system. The ball screw provides the linear motion along with a linear rail that took out the moment of the system. The potentiometer measured the position of our actuator, and it was all encased within an aluminum housing. All components were designed to be easily assembled with the correct alignment, as well as easily disassembled to allow for replacement parts to be installed. The requirements that were met are shown with a green check next to them. The cycles were tested for 5% but were not completed due to a time constraint. The red X shows the requirements that could be met with further optimization. Of the $4,000 we had in the budget, we spent less than half at $1,900, leaving $2,100 left unspent. It is necessary to conclude the cycles test and introduce the actuator to the extreme environments that it will be operated in. Further redesign will be done to optimize the space, weight, and cost, and improvements on the assembly will be made.